Alright, let me quickly share with us here how to use a potentiometer to control the brightness of a LED and the speed of a DC motor. So we're going to be drawing the circuit diagram here, and let me show you how to do that in Proteus. So I discover that, let's start afresh. So under Arduino, I discovered that the Arduino here does not work perfectly when I'm using analog input functions. So especially I tested this and this. I didn't test this, I didn't test this, but this is the one I finally used. This Arduino open bracket log Embarcado, this one here. So select this, you see Simulino Uno. Just select the Uno one. Just select, I use this, so let's select this. So that is selected. Then we need a light emitting diode. It's under optoelectronics. Let's select color red. Then we need a potentiometer, so an active one that we can vary. So and that is port HG, port HG. So bring it out like this. So select that. We need an electric motor. We can use an acceleration, just type motor. Maybe go to electromechanical, or you can just select from here. You have the motor active. So you can use any one. You can use this one or this one. I'm looking for one that will show you a real life simulation. I used, let's use this. Let's use this. Then you need a transistor to drive the motor. I use the BS170 MOSFET transistor. It's a small signal transistor, can handle up to 500 milliamperes at 60 volts, which is more than enough to drive a small electric motor. Okay, so let's select that, and we need a resistor. I select my resistor from, oh sorry, my spelling is wrong. I always select my resistor from modeling primitives from here, so I won't have to waste time looking for the right resistor to use. So that being selected, and that's what we'll be needing. So the first thing I drop my Arduino. The second thing, let's connect our LED. Let me zoom in. Our LED is connected to pin 9. Pin 9. So draw. Now the value of the LED, the resistor is not going to be 10k. If you are using a 5-volt system, just like Arduino, most Arduinos run on 5 volts. There are Arduinos that runs on 3.3 volts, but Arduino Uno runs on 5 volts. Now, if you are using a 5-volt system, the value of your resistor should be 220 ohms. So to change that value, double click the resistor. When it is highlighted like this, double click it and change the resistance here. So that being done, I can go ahead and connect my LED. Rotate it until it faces the right direction. Then they add the ground pin. So that is done. The next thing is to connect the motor, the electric motor. It's going to be connected to another resistor. Pin 10. Now the value of this resistor should be around maybe 100 ohms. 100 ohms is good. So we go to the gates of the MOSFET. Then the source of the MOSFET, the source, this is the source here, this connection is the source, it goes to ground. You can connect your electric motor now, a DC motor. The other side goes to positive supply. So that's the mistake. Positive supply. Now to check the parameters of this electric motor, you can just double click. So you discover that the nominal voltage is 12 volts. The coil resistance, the coil inductance, the zero load RPM, the load maximum and all this stuff. What we actually need here is this 12 volts. That means this power supply here must be at 12 volts. To do that, just double click this supply symbol and add plus 12 volt here. When we do that with this line, this electric motor is now powered by a 12 volt supply. And the last thing to do is to connect our potentiometer at A0. So go back to components mode, potentiometer, where are you? Yes. Let me change it so that this side is facing this side. I just flip. Alright, so connect the center pin to A0, then connect the upper and the lower pin to positive and ground. 5 volts, please. In no wise should you allow more than 5 volts to enter into your Arduino pin. In no wise. You will destroy that particular pin. It won't work again. So it can't tolerate more than that. If you are using a 3.3 volts Arduino board, let it, whatever input you are passing into the board, it must not be more than your supply voltage of the Arduino. It must not. So keep that in mind. Now that we've drawn the circuit diagram, let's proceed and add our code to this Arduino board. So this is my own code here, already compiled and already exported. So let's go and add it to the Arduino board. So click this folder symbol and I will take it to where my code is stored. So my code is stored under Arduino, LED brightness, then here, click OK. Now we are ready to simulate. Just go ahead and click play. Let's see the output. Now, as I've said earlier, you may see the LED flickering. It's simply because, check my time here, check the time that is here. It is not up to 1 second yet. So this simulation is running in 100 or less than 100 milliseconds interval, which allows you to see actually the persistence of the eye can catch any picture that is lesser or that is higher than 100 milliseconds. If it is higher than 100 milliseconds, or even I think if it is higher than 50 milliseconds, your eyes can still catch it. But if the speed is lower, if it's now 10 milliseconds lower and down, you see everything as a single picture. So that's why, because the speed here is so slow, and so it can't catch up. Now my electric motor is not running. Let me increase the potentiometer and see what we've got. Oh, there's a mistake. There's a mistake in the connection. Look at this. This is connected to pin 11 and this is connected to pin 10, which should not be so. So I'm going to delete, and let's reconnect. The LED goes to pin 9 and the motor goes to pin 10. Now let's play again. So that explains why the motor was not indicating any movement. So see this value, you discover that the value has increased. So look at the value more than the motor itself. It actually moves, but because we are in simulation, so you may not see real life expectations. So let's increase it further. Discover that the LED is more stable now and brighter. And let me increase it to the maximum by clicking the plus button. You see, my motor is beginning to show signs of movement. So it's beginning to turn. So I'm going to allow it stay. This is the LED also is at the brightest level. So it's beginning to turn. Let me give it some time. Let's give it some time so that the electric motor can reach quite a high number. Then we turn down our potentiometer to see the effects on this increasing number. Please, if you have any challenge using this simulation, just drop your question on the group and I will be ready to answer you right there. Okay, we are reaching some stable figure, 150, 151. Now let's drop the value of this potentiometer by clicking this down arrow, and let's click and hold. So by that we are reducing the value of the potentiometer. So your LED is beginning to show. You see the value of on your motor is reducing. 160 now, 159 now, 158, 157, 156. Let's reduce it further. Now 154, and that's how it begin to drop and drop and drop. You know, actually in real life too, an electric motor does not stop rotating immediately. Although there are advanced control system where you can do what you want with an electric motor, there's a circuit called H bridge circuit. Let me take it again. H bridge circuit. With an H bridge circuit, you can make a motor run in the forward direction, in the reverse direction, or in a brake mode. For example, let's say the motor was running and running and running, and you want to apply an instant brake, just like a real car brake. You can do it with an H-bridge circuit such that the electric motor will come to a halt immediately. So there's a lot more to learn. So this is how to control the speed of an electric motor, a simple way to control the speed of an electric motor, and also the brightness of a light emitting diode. Thank you.